Hello, this is Professor Steve Potter. Welcome to my booth number 42 at the 2021 Dublin Maker. And I'm going to show you the mostly printed CNC that I've been building for the last few months. I'm following the design by Ryan at v1engineering.com called MPCNC. This is the second version of that called Primo, and MPCNC stands for Mostly Printed CNC. If you buy the kit, which you can see here is about $230, you get all these stepper motors, power supply, bearings, bolts, nuts, cog belts and cog wheels, lead screw. You have to print all the parts, or you could order them from somebody else who's willing to print them for you for about $165. So for well under $500 you get a completely functional CNC machine. It's good for not just cutting wood, but even aluminum and other soft metals. This website also has a fantastic forum where people will give you lots of advice on building CNC or using it. They have a lot of examples of things that they have made and done with their CNC machines, and it's a very friendly forum. So I highly recommend it just for the fact that you have a society of people that have built the same machine. The main thing that makes my MPCNC different than all the other ones that I've seen so far is that I wanted to make mine portable. I teach workshops in various maker spaces across Ireland, and I want to be able to put it in the back of my car and easily wheel it from here to there, in and out of buildings and whatnot. So that means that I had to make a base for it that was light enough to lift into the car. And for that I used a Torsion Box. I made it out of this 9mm thick plywood, which is quite light and fairly flimsy, but when you glue all these pieces together with a lot of Titebond 3 glue, you can see that I put a lot of fillets of glue everywhere inside. It becomes amazingly strong. I also lacquered the inside of it before I glued it together to make sure that it wouldn't absorb too much water from the atmosphere, and I also lacquered the outside of it so it's pretty well protected from warping due to moisture, which of course there's a lot of here in Ireland. The original design for the MPCNC used American style conduit, 1-inch galvanized steel conduit as the rails for this CNC machine. And I felt like, well, number one, I'm in Ireland, so it's hard to find such tubing, but I think that tubing is kind of flimsy, so I got stainless steel tubing, which is 2mm thick, commonly used for rails. To make the whole thing as stiff as it can be, you can see that I have drilled holes through the Torsion Box and also through these plywood stiffener blocks that I have glued in, so that I can put the 4 legs right through there and clamp them in place with hose clamps. The Torsion Box came out very flat and stiff. It's flat to less than 0.5 millimeter across its area, so it's 1,000 millimeters by 600 millimeters, and the work area is 2 feet by 1 feet, or 630 millimeters by 320 millimeters, and it weighs under 11 kilograms. Just enter MPCNC Primo into the YouTube search bar and you'll see all sorts of videos that people have made about their mostly printed CNCs. One of the nice things about the MPCNC and Primo specifically is how hackable it is. You can pretty much change all the basic parameters of it to suit what size of it you want, and also what you use for the spindle. The actual carving machine could be a router, could be a spindle, could be It could even be a laser, it could be a 3D printer, it could be a vinyl cutter, drag knife, or who knows what you could stick on there. You know, it's just a device for moving something very precisely in 3 dimensions. The first thing I did when I got my MPCNC working was to attach a ballpoint pen to the spindle holder so that I could make some test drawings to see whether it was well calibrated, to make sure that the axes were square and perpendicular and aligned with each other. And you can see that the numbers here that are 3 millimeters high came out very well. I'm going to show you now how portable this thing is. First I'll disassemble the wires. We've got a lot of wires here. I suppose the first and most important one is the mains plug is unplugged. I have a Z plate that goes in a little satchel, and all of these wires are going to fit inside here. The next one would be various motor wires. The end stops wire. Okay. And then finally, we've got these hoses which have quick release connections. Cooling systems wire. And I'm also going to put my crucial tools. These are for putting a new bit in the spindle, and this is for adjusting the clamps that hold the motor. Okay, so now I'm going to get these things to sort of out of the way somewhere. And maybe tie one for a bit of Velcro. Flop around too much. And the electronics, the cooling system. Top comes away. Okay, so now we're going to put the other wheel on. These are pneumatic scooter wheels, which are going to absorb shocks going over rough surfaces like I have in my driveway here. I have nylock nuts and a little 3D printed wing nut here, and I've got a brake that I'm going to stick in here to prevent it from rolling while I take it down from the table. I've got brakes on both sides. And we've got handles here. Okay. Okay, so I've taken out one of the brakes. We've got the other brake. And now the thing can roll. And you want to be careful not to drop it, I suppose. However, it's got pneumatic tires so it can handle a little bit of shock. There we go. You get it connected to the car, put the brakes in. Safely lift it into the car with the handles. There you go. I'm using this 1.5 kilowatt three-phase water-cooled spindle instead of a brushed router like the one that I use on the HandyBot CNC machine, because it's much quieter and of course it's much more powerful, especially at low revolutions, which allows me to cut metal. I built a cooling system for it that could easily be tucked behind the front seat when the back seat is folded down. It uses these quick release connectors that have valves in them that shut when you disconnect them so that they don't drip coolant all over the place. It uses a radiator and fans that are normally used for cooling a CPU and a little submersion pump there. I've got an ESP32 microprocessor that is monitoring the temperature of the coolant going into and out of the radiator to make sure that the cooling is working, and there's a little buzzer there in case for some reason something goes wrong. It'll let me know that. Now a little bit more about the electronics. I have inside this toolbox everything I need to control the MPCNC. In the yellow enclosure that I 3D printed is an Arduino Mega board, and on top of the Arduino is attached a ramps shield which carries the stepper motor drivers. To the right of the box, in the black box there, is the variable frequency drive that controls the spindle motor. There's a brake for stopping the spindle quickly. There is power supplies for the Arduino and for other electronics such as the fans. The red circuit board is an LCD user interface that you can control the thing autonomously. You can put a job on an SD card and plug it into this so that it can run all by itself without a computer, which is very handy. So on the ramps board are the 5 DRV8825 stepper motor driver boards. I've glued temperature monitors to each of them to the heat sinks to see whether I'm driving them too hard. I've also got the temperatures being read out on these two ESP32 boards, as well as the temperature of the VFD, the variable frequency drive of the spindle motor, and the box ambient temperature, and also the stepper motor currents and powers. All CNC machines need to have some way to know where they are as they move around. The way this one does that is with end stops on the X and Y axes. These little things clamp onto the bars, onto the rails that the trucks slide along. And I've glued these Hall effect sensors to each one. These are switches that switch when a magnet gets close to them. So the truck has a magnet glued to it, and these are stationary. And when the thing comes closer to the zero location of its axes, these things switch and tell it where it is. So that's how you get the 0 point for the X and Y axes. Most people are using micro switches for that, which could be susceptible to dust or mechanical fatigue. Hall effect switches will never wear out, and they're not influenced by dust or vibration or other such things. Also, they have a very clean signal that switches within about 100 nanoseconds or so without bouncing. So they have some advantages. They're very cheap too. They're used in cars, for example, like to know whether you've left a door open or you forgot to plug your seatbelt in. For the CNC machine to know where it is on the vertical or Z-axis, I use this aluminum plate that I have sanded very smooth and attached a wire to. I also grounded the spindle motor so that when it lowers a bit down to touch the metal plate, it sends a signal to the control board to stop moving and to say that the 0 point is a certain distance, in this case 3.09 millimeters below that top surface of the plate there. So that's how to set the Z0. The end stops set the X and Y zeros, and then the machine knows where it is as the stepper motors move it around in a very reproducible way. Once you get into CNC, you'll realize that the time that you spend carving is actually much less than the time that you spend designing something. So I'm going to go through briefly the design process. I had this acacia cutting board that was worn out and said I'll make a plate out of it. So here it is doing the roughing pass of the carving. In order to get to that stage, I used VCarve Pro to design this plate. It's an ellipse, and it's the first two-sided job that I've done, so I put dowels in certain key locations on the board that I could flip it over and replace the thing upside down and carve the underside of it. So I used their toolpath called the molding toolpath, which is that the little symbol in the upper right that's highlighted. You have to first draw a curve of a certain shape, in this case what the curve of the inside of the bowl or the plate will be like, and then tell it to follow that inner ellipse all the way around to make a lip. And then it will produce this kind of a tool path with lots of lines that the bit will follow as it's doing the carving process. Then you go on to use a flat end mill to cut out most of the wood. That's called the roughing pass. And then you switch to a round end mill or a round fluting bit to do the curved carving. And this is what it looks like in the carving process there. In this software, and VCarve Pro can make nice simulations of what the carving will look like, and they're pretty accurate. You can see here how it looks as it was doing the final cutout there. I also had to design the underside with a different shaped curve and then carve that. Do a lot of sanding, finishing, and branding. And here's how it came out after the finishing on the top surface. This was made out of acacia wood, this cutting board. I also used a solid piece of red oak for another plate, and that came out pretty well. I was very pleased because this is much harder than the acacia wood. A couple of more customizations that I did for my machine. I installed these cable chains to keep the cables and the cooling tubes out of harm's way, and also to keep them off of the substrate, because that way I can feed boards in from the front or the side if I have a long sign that I'm carving, for example. And you can also see there's a flow meter for the spindle coolant so it spins around, allows me to see whether the coolant is flowing. In order to hold these things up off the substrate, I had to redesign these little clamps to hold the molding, this corner bracket molding that the cable chains rest on. And all of the 3D printed parts that I have on my CNC are made from this ABS carbon filament by Kimya that is much more heat tolerant. So if it's going to be sitting in a hot car, I didn't want it to warp or deform from the heat. Finally, and this is still a work in progress, I built a dust shoe that is attached to the bottom of the core that holds the spindle motor. It is attached to a vacuum system to suck up all of the sawdust that's going flying everywhere when I'm doing, for example, facing the spoil board like in this picture. And you can see that there's a big hose that's going to a big vacuum over there. This, in its current design, it's really only good for very thin stock, so I'm going to make a new version which is more adjustable than this, that will allow me to set it to the right height for however thick my stock might be. If you're watching this, you're probably at the Dublin Maker Fair, Saturday, June 19th and Sunday, June 20th, 2021. If you missed it, you can go to dublinmaker.ie and learn all about the presenters there. My booth is M42.